Yes. I got the pleasure of playing with Chuck's chip in Colorado for a year, and played with some toys, made some toys. And this is the agenda, and you'll notice that there is a link there. And that takes you to where I have put the toys. They're up on Code Google VF plugins. And up there that I've got basically 3 packages for download, plus this database one. Some of the packages require this database one. This is the old Polyforth database package. Fairly lightweight database. So now, what are in each of those little things? Oh, that was the wrong one. What I have done in each of these packages is I've used LaTeX, wrote a little bit of a support routine, and made it so I can produce LaTeX documents for every one of these plugins. That allows me to get some fairly standard documents.
The projector has decided it's too hot. It will take a minute for it to cool down enough for us to tell it, no,
Okay. Okay. So I create these LaTeX documents, and I've got each little dinky piece of the plugin architecture organized very much like the Fourth Foundation libraries. That I've got little pieces that if you need this piece, you include in that piece. I added into it, additionally to what the FFL does, is I added version numbers so I can check whether it's the latest version. And if it's not the version I expect, I tell you, reinstall your system. Because the idea was that you were going to have multiple of these plugins, and they could get mismatched. So, okay. There was, Les Snively was the one running it there. He was the head. It was myself, 2 other programmers, and a hardware tech. So 5.
What was the end product, if you can tell us?
What we were trying to accomplish was wireless speakers that knew where they were in the room, that all communicated to each other. Basically a software radio. And we got the antennas about 3 foot apart. That was it.
You were bit bagging straight from one of the output port pins to an antenna?
Actually, from one of the A to D converters to the D to A converter on the other side.
Oh, you had an
Yes, Chuck's chips have 2. The 24-pin or node chip has 2. Okay, we're back. So, we've got these little documents for each of them. They're very similar templates. I've released all of this stuff on the MIT copyright familiar. It's their listing that they suggest for MIT license. This is the contents. This is a very small document. This is the background of how we started it. Les basically came up with the idea that he wants to be able to name the nodes. And so we're naming the nodes. with various different status indicators and allow various size chips. Originally, when we started out with a 4x4 in an FPGA package. By the end, made it up to the 24 node chips, so we didn't quite make it to the 40 in what we were doing. Installing it, these are basically zip packages. You unzip the zip inside of the VentureForth compiler. It adds some more directories and a whole bunch more files. Those are the installed files. The VentureForth has a projects. This creates another floor plan under the projects. Under the VentureForth, it creates a plug-in directory and adds all these extra files. Inside the VentureForth file also is a gforth.fs that allows me to use gforth with the VentureForth compilers. This is the validating that I already talked about. File dependencies that it uses. It uses all the stuff out of the VentureForth for the various, this is the chip for the fourth files, and not much, doesn't use many. This one doesn't have any, just garbage. Then these are actually the commands that are used to create the floor plan model. And I'll show you the floor plan, the results of these. People would be able to want to run our applications that didn't have the plugins. The basic thing that I redefined was left paren. Left paren goes out and looks in for each one of the words. It looks out into a comments vocabulary, and if it finds it, it executes it. If it doesn't find it, it ignores it, just like a comment. So it ends comments so I could put things in comments. And these are the various things that I put into the comments to create basically arrows. And these are the generation words there. And so the example, you'd have something like this. I've got to blow this way up so you can see it. So the code would basically look like that, sprinkled various places within your code. That would basically, this would set up which node you're in. If you weren't already in a node like here, this is the normal way of VentureForth to create a node. This inside the comments would name the node, give it a color, set the status text, and actually compile some stuff into the node there. And that's the standard ending. And in the end, what it does, actually let's go over to a better picture of that. There's what it would create. In a 24 node with various colors, and some of them are hard to write. The stuff in the background that you see in the text, those are some node timings that are another one of the little projects I did on the fourth drive to compare how long it takes to run things on various nodes. But you would have, as you execute things, you can have arrows between the nodes, into and out of the nodes, arrows going out representing the I/O pins, arrows going diagonally representing other things because I ran out of places to put arrows, and basically a pattern like that. Now we'll look at a little bit of, this is basically the Venture Forth system with the projects. That's the Venture Forth system that gets delivered from them. I add in this plugins directory. Within the projects, then this floor plan is just a very simple project that actually does not do much. And I haven't loaded, that's the one that I didn't load up. Here's an editor. And it's nice to run Windows that even X takes a long time to load. Make it so we can actually see it. And this set of code adds some functions. These are where all those numbers came that I did timings in another one of my projects that I have there. This file actually very similar to what I had in the document, that it sets the color, node names, and the status. And that's floor plans. That we had here was actually one that came first. Oh, shoot. Don't do that to me. There we go. Plugin is actually a test suite. Suite is that I have running around my various places wherever I test. It dumps the stack. Distribute them on the stack. That allows me to tell the difference between thousands of these. So I wanted to do that same type of concept inside the Venture Forth simulator. So I extended the whole thing and got into some of the philosophy of testing and test suites and the whole bit. And so I came up with, this is all just boilerplate mostly, that here's the interface, that there I'd have my dot, which allows me to do the fence post is what I call that, is a fence post. I can sprinkle those within my Venture Forth code that's going to go on the chip, but will do something in the simulator. In this case, dump back in the simulator. And assert colon, and semicolon, that would do programmable something inside the simulator, which allowed me then to, again, we have to blow up, put things within my Venture that pick up the T in the simulator data. The assert colon, if what was left on the stack is true, it does nothing, except for set a few indicators that it ran. If it was false, it would put up an error message, and you would actually work within the simulator. And finish test allowed me to if any of you have run the Venture Forth simulator, it basically runs one step at a time. What I wanted to do in addition to that is I added this goes word. That goes until it has executed, in this case, execute. So it would run that many times and then finish and put out a summary. Against the simulator. And we could do regression testing then as we ran through our system. The example that I put out with this one was just a simple something that did a checksum on the code that was downloaded to each of these routines. And when it was finally done, it would use the LED that's on the fourth drive to tell me whether everything was okay. Which was an interesting concept that I had to try. But if you notice, what is underneath here on the status lines is how full those chips are. And just the checksum alone and stuff to around that no application. A problem. So the checksum was a resounding failure. The test suite frequently. That's the second. And actually I did the test first before. That was just the way it went there. The next little plug-in, how am I doing on time? 14 minutes, is a timing suite. And this one, TPL is still trying to create a patent for. I keep on watching it, and it's somewhat going. I'm not sure if they're continuing, though. I'm not sure if he's still putting money into it. But maybe someday. And what's interesting here, this is some of the text out of the patent. Basically what a timing diagram allows you to do. The interface, here I had to hook into Venture Forth. Each one of these plugs has to hook into Venture Forth and the simulator even further. This one starts getting rather deep. And this is one of the objections to it. Basically, its user interface is that the simulator is running. It watches the simulator run. And here's an example of some of the extra stuff I've got to do to set it up to run. Again, I'm using this checksum application. That one does a timing diagram that I'll show you in a minute. This is loading up the timing diagram code and checks that it is this version. As soon as I do my first checksum is when I start saving events. And that prints the floor plan. If I've got the events defined, I initialize the events database. This is powering up the simulator. Then I just run the simulation. And when I'm done, I just print out these things. And both within the floor plan diagrams. I've got an SVG version and a PDF version. The SVG is scalable vector graphics that is starting to get talked about again. It's supposed to be in browsers. It's not in very good in browsers yet. PDF is what everybody knows, that I generate the PDF files. Now here we come to a timing diagram. The output of this thing is over here on the left-hand side is clock ticks. On the right-hand side is supposed to be time, but I haven't timed the fourth drive yet. I haven't gotten out to find out exactly what it means. You're not supposed to talk about clock. Each step takes. And it's asynchronous, so the simulator was basically lying to you too. Some of the fun problems with working with the simulation of the chip. But this basically what's going on between nodes on the chip. Go down one more so we can see this whole thing. And basically this is saying that data from node 1 got passed to node 0. Node 1 sent it up here, but node 0 didn't take it until down here. So node 1 was asleep all that time. And the blue lines are passing to the left, the green lines are passing to the right. And so you get these interesting diagrams of the process of passing the checksum status all the way back down to this node here, and I forgot what node that was, node 18. They all get passed down to node 18. And then node 18 passes up to 19 and blinks the LED in 20. So that's timing diagrams. 9 minutes. Any questions? I'll stop there until questions. No questions. And all of this stuff is online if anybody wants to take a look at it. There is one other plugin that I haven't published yet, and that one is a case whether with a simulation, a program hook it up to the real world somehow or simulate the real world. So the other plugin that I connect input and output pins to each other through the simulation, and to plug things into the A to D converter as if they came in the real world. That is the Connect, and I haven't updated this one to the new template yet, but it basically follows the same basic form. Basically, it would allow me, was it here that I've got it? Yes. I could take in the signals that we were analyzing and pump those right into the A to D. I could capture them with a scope into a data file and then plug them right into the simulation. And it allows us to test some of our code through the simulation. This one gets even more complex and buried into the simulator. And the example application that I've been using on that one is a poor man's spectrum analyzer. right on a fourth drive. And it's close. I've got a lot of it working. It basically has an FFT algorithm. And the timing diagram FFT algorithm running on the chip. As it pulls the data in, the data is running off the A to D, so it pulls in at specific time cycles. Each of those are quarter. It's trying to analyze a QAM radio signal, is what we were working with. And the FFT would do the analysis of that. And I haven't worked out all the details yet. Changing jobs has gotten in my way. And that's what we got. Eventually I might post, but then Chuck's going to do a new simulator. Yes? Absolutely. What they allowed us to do is find out when we had a mismatch in our timing between two nodes. We could tell on various patterns that we missed a node. We didn't collect the data in time for it to, without missing the next signal coming in. We could find when we missed the windows graphically, and you could actually see them. So it helped a lot for what we were trying to accomplish. Doing an FFT takes almost the entire node, which is 48 words. What were they on the fourth drive, on the 24? 64 words. 64 words. But that takes 8 nodes to do that. Each node does half a butterfly. Eight. I don't know. I haven't timed it yet. Well, actually, it's running on the chip. I have it running. The fourth drive has an interesting USB interface device which makes it fun to do timing. I haven't figured out how to time the chip with a PC with a USB in the middle. Simulation, we have that. Get out of there. So simulation-wise, I can't read that. So say we're about a little bit before the 15,000, and we run over to about, it'll be about one of those squares. So about 500 clocks. What was that? 1.6 microseconds? Nanoseconds. So 750 nanoseconds. FFT. Yeah. cranked on that algorithm for a long time. The biggest problem is getting the data into the algorithm and out of it. There's all your time. I cannot do it across the USB. I don't know. Yeah. Those guys know about a lot more than I do. Okay? Yeah, this project is real interesting, but it's taken me a lot of time to get it posted. I have to get it finished. Any other questions? Okay. There's 1 minute left.